Question 1. Investigation of the potential consequences of a planned upgrade to the BGP routing policy used for VPN traffic aggregation on a service provider's network, without a formal impact assessment, would most likely lead to which of the following outcomes? Option A. A minor increase in control plane overhead, easily managed by existing network monitoring tools without affecting service. Option B. Improved BGP convergence times and more efficient route propagation, leading to enhanced VPN service stability. Option C. Enhanced security by inadvertently blocking unauthorized BGP updates, strengthening VPN isolation. Option D. Unforeseen routing loops and traffic blackholing affecting multiple customer VPNs, potentially causing widespread service disruption. Correct answer is D. Unforeseen routing loops and traffic blackholing affecting multiple customer VPNs, potentially causing widespread service disruption. Explanation. This scenario presents a professionally challenging situation due to the critical nature of VPN services in a service provider environment. The impact of a misconfiguration or a failure to adhere to established protocols can lead to widespread service disruption, financial losses for customers, and significant reputational damage for the service provider. The need for a thorough impact assessment before implementing changes is paramount to mitigate these risks. Careful judgment is required to balance the urgency of implementing new features or fixes with the imperative of ensuring service stability and security. The correct approach represents best professional practice because it prioritizes a systematic and controlled method for evaluating potential consequences. By conducting a comprehensive impact assessment, the service provider can proactively identify and address any adverse effects on existing VPN services, network performance, security posture, and customer experience. This aligns with the implicit regulatory expectation of providing reliable and secure services, even if specific regulations for this exam are not explicitly stated as US, UK, or Australian. The principle of due diligence in network operations is a universal professional standard. An incorrect approach that bypasses or inadequately performs an impact assessment is professionally unacceptable. Such an approach demonstrates a disregard for potential negative consequences, leading to a higher probability of service outages, security breaches, or performance degradation. This failure to exercise due diligence can result in breaches of service-level agreements, SLAs, customer dissatisfaction, and potential regulatory scrutiny for failing to maintain service integrity. Ethically, it represents a failure to uphold the responsibility of providing a stable and secure service. The professional decision-making process for similar situations should involve a structured risk management framework. This includes 1. Clearly defining the proposed change. 2. Identifying all potential impacts across different service domains, performance, security, availability, customer experience. 3. Assessing the likelihood and severity of each impact. 4. Developing mitigation strategies for identified risks. 5. Obtaining necessary approvals based on the assessment. And 6. Implementing the change with robust monitoring and rollback plans. This systematic approach ensures that decisions are informed and that risks are managed effectively. Question 2. What factors determine the successful integration of a new service provider VPN solution into an existing network infrastructure, considering potential impacts on service availability, security posture, and operational efficiency? Option A. The perceived market appeal and the ability of the new VPN service to attract new subscribers based on promotional materials. Option B. The thoroughness of the technical and operational impact assessment, including compatibility testing, security vulnerability analysis, and performance benchmarking against current network capabilities. Option C. The extent to which the new VPN solution offers the lowest initial acquisition cost compared to alternative offerings. Option D. The reliance on vendor assurances regarding the VPN solution's capabilities without independent verification or testing. The correct answer is B. The thoroughness of the technical and operational impact assessment, including compatibility testing, security vulnerability analysis, and performance benchmarking against current network capabilities. Explanation. The scenario of implementing a new VPN service for a service provider involves significant impact assessment due to the potential for service disruption, security vulnerabilities, and compliance issues. The challenge lies in balancing the introduction of new technologies and features with the need to maintain existing service levels, protect customer data, and adhere to relevant regulations. A thorough impact assessment is crucial to identify and mitigate risks before deployment. The correct approach, focusing on a comprehensive technical and operational impact assessment, represents best professional practice because it directly addresses the core requirements of implementing a new VPN service within a service provider environment. This involves evaluating the proposed VPN solution against existing network infrastructure, security policies, and operational procedures. It ensures that the new service integrates seamlessly, does not negatively affect current operations, and meets all technical specifications and performance expectations. Furthermore, it aligns with the principles of responsible network management and service delivery, which are implicitly expected by regulatory bodies overseeing telecommunications and data services, even if specific regulations are not explicitly cited in the exam context. The focus is on ensuring the integrity and reliability of the service, which are foundational to customer trust and regulatory compliance. An incorrect approach that prioritizes only cost reduction without a thorough technical evaluation would be professionally unacceptable. This is because it risks deploying a solution that is technically inadequate, insecure, or incompatible with existing systems, leading to service failures, data breaches, and potential regulatory fines for non-compliance with service availability or data protection standards. Another incorrect approach that focuses solely on the marketing benefits of the new VPN service, neglecting the operational and security implications, is also professionally flawed. This oversight can lead to a service that is attractive on paper, but fails to deliver reliable performance or adequate security, resulting in customer dissatisfaction and potential breaches of service-level agreements, SLAs, which often have regulatory implications. A third incorrect approach that relies on anecdotal evidence or the vendor's claims without independent verification of performance and security is professionally unsound. This lack of due diligence can result in the adoption of a solution that does not meet the stringent requirements of a service provider network, potentially exposing the provider and its customers to security risks and operational instability, which could lead to regulatory scrutiny. The professional decision-making process for similar situations should involve a structured risk assessment framework. This framework should include identifying potential impacts, technical, operational, security, financial, regulatory, analyzing the likelihood and severity of these impacts, and developing mitigation strategies. For a service provider VPN implementation, this means engaging all relevant stakeholders, conducting thorough testing in a lab environment, performing security audits, and developing rollback plans. The decision to proceed should be based on a clear understanding of the risks and the effectiveness of the proposed mitigation measures, ensuring alignment with business objectives and regulatory expectations for service quality and security. Question 3. When evaluating the implementation of a new service provider VPN service, which approach best ensures adherence to the regulatory framework and protection of customer data? Option A. Prioritizing the fastest possible deployment to gain a competitive advantage, with a plan to address any regulatory issues that may arise post-implementation. Option B. Focusing exclusively on achieving the lowest possible operational costs for the new VPN service, even if it means using less robust security measures. Option C. Conducting a comprehensive impact assessment that prioritizes regulatory compliance, data privacy, and potential service disruption against all applicable laws and guidelines. Option D. Implementing the VPN service based on the latest technical specifications and performance benchmarks, assuming that regulatory compliance will be implicitly met. The correct answer is C. Conducting a comprehensive impact assessment that prioritizes regulatory compliance, data privacy, and potential service disruptions against all applicable laws and guidelines. Explanation. Scenario analysis. Implementing a new VPN service within a service provider network, especially one involving sensitive customer data, presents significant challenges. The primary challenge lies in ensuring that the chosen implementation strategy not only meets technical performance requirements, but also adheres strictly to the regulatory framework governing telecommunications and data privacy within the specified jurisdiction. Failure to do so can result in severe penalties, loss of customer trust, and operational disruptions. The need for a robust impact assessment is paramount to proactively identify and mitigate potential risks before deployment. Correct approach analysis. The correct approach involves a comprehensive impact assessment that prioritizes regulatory compliance and customer data protection. This means thoroughly reviewing the proposed VPN implementation against all applicable laws and guidelines related to data privacy, service availability, and network security. For instance, if the jurisdiction mandates specific encryption standards or data residency requirements, these must be explicitly verified. The assessment should also consider the potential impact on existing services and customer experience, ensuring that the new VPN service does not inadvertently violate any service-level agreements or regulatory obligations. This proactive, compliance-first methodology represents best professional practice because it aligns with the ethical responsibility to protect customer data and uphold legal mandates, thereby minimizing legal and reputational risks. Incorrect approaches analysis. Focusing solely on technical performance metrics without a thorough regulatory review is a significant ethical and regulatory failure. This approach risks deploying a service that, while technically sound, violates data privacy laws or other telecommunications regulations, leading to fines and legal action. Prioritizing cost reduction above all else, without adequately assessing the regulatory implications, can also lead to the selection of solutions that compromise security or compliance, resulting in regulatory noncompliance and potential data breaches. Similarly, adopting a move fast and break things mentality, common in some agile development environments, is entirely inappropriate in a regulated service provider context where stability, security, and compliance are non-negotiable. This approach can lead to unforeseen regulatory violations and service disruptions. Professional reasoning. Professionals tasked with implementing new network services must adopt a structured decision-making process that begins with a thorough understanding of the regulatory landscape. This involves identifying all relevant laws, regulations, and industry guidelines. The next step is to integrate these requirements into the technical design and implementation plan from the outset. A risk-based approach, where potential impacts on compliance, security, and customer service are systematically evaluated, is crucial. Before deployment, a formal review process involving legal and compliance teams should be conducted to ensure all regulatory obligations are met. This systematic and compliance-driven approach ensures that technical innovation does not come at the expense of legal and ethical responsibilities. Question 4. Quality control measures reveal a potential issue with the distribution of VPN routes via BGP between provider edge P routers. While the VPN service appears to be operational for most customers, there's a concern that route propagation might not be adhering to the intended security and isolation policies. Which of the following verification strategies would best address this concern and ensure the integrity of the VPN service? Option A. Rely on the absence of active BGP session flapping or immediate error messages reported by the network management system, assuming that if no alarms are present, the route distribution is functioning correctly. Option B. Perform a quick syntax check of the BGP configuration on the PE routers to ensure there are no grammatical errors, and then proceed with deploying the configuration to all devices. Option C. Assume that if the VPN service is generally available and customers are not reporting widespread connectivity issues, the BGP route distribution is functioning as intended and no further investigation is required. Option D. Conduct a comprehensive review of the BGP configuration on all PE routers involved in VPN route distribution, specifically validating the correct implementation of route distinguishers, RD, and route targets, RT, against the service design. Subsequently, perform operational tests to simulate route injections and withdrawals, verifying their accurate propagation and adherence to defined VPN policies. Correct answer is D. Conduct a comprehensive review of the BGP configuration on all PE routers involved in VPN route distribution, specifically validating the correct implementation of route distinguishers, RD, and route targets, RT, against the service design. Subsequently, perform operational tests to simulate route injections and withdrawals, verifying their accurate propagation and adherence to defined VPN policies. Explanation. Scenario analysis. This scenario presents a professional challenge related to ensuring the integrity and security of customer VPN services, specifically focusing on the implementation of BGP for VPN route distribution. The challenge lies in balancing the need for efficient and scalable routing with the critical requirement of preventing unauthorized access or route manipulation that could compromise customer data or service availability. The service provider must adhere to strict operational and security guidelines to maintain customer trust and comply with industry best practices, which are implicitly governed by the principles of reliable and secure network operation expected within the scope of the SPVI certification. The potential for misconfiguration to lead to service disruption or security breaches necessitates a rigorous and methodical approach to verification. Correct approach analysis. The correct approach involves a comprehensive verification strategy that includes both configuration review and operational testing. Specifically, verifying the BGP configuration for VPN route distribution against established design principles and security policies is paramount. This includes checking for correct route distinguisher, RD, and route target RT configurations, ensuring appropriate BGP communities are used for policy enforcement, and confirming that loop prevention mechanisms are correctly implemented. Furthermore, performing operational tests such as route injection and withdrawal simulations, and verifying that these actions are correctly propagated and honored by PE routers is essential. This approach aligns with best professional practices by proactively identifying and mitigating potential misconfigurations before they impact customer services, thereby ensuring service availability, security, and adherence to service-level agreements. It reflects a commitment to operational excellence and risk management, which are core tenets of professional network engineering. Incorrect approaches analysis. One incorrect approach is to solely rely on the absence of immediate alarms or error messages. While the absence of alarms might indicate no immediate system failure, it does not guarantee correct functionality or security. BGP misconfigurations, especially those related to VPN route distribution, can be subtle and may not trigger immediate alerts, but could lead to incorrect routing, data leakage, or denial of service over time. This approach fails to proactively validate the intended behavior and security posture of the VPN service. Another incorrect approach is to assume that if the VPN service is generally functional for most customers, the BGP configuration for route distribution is correct. This overlooks the possibility of specific, targeted misconfigurations that might affect only a subset of customers or specific traffic flows. It also fails to account for potential security vulnerabilities that might not manifest as immediate functional issues but could be exploited later. This approach is reactive rather than proactive and does not meet the professional standard of thorough verification. A third incorrect approach is to only review the BGP configuration syntax without validating its operational impact. While syntactically correct configurations are a prerequisite, they do not guarantee that the intended routing policies and security controls are effectively implemented. Operational testing is crucial to confirm that the configuration behaves as expected in a live network environment, ensuring that routes are distributed correctly and securely according to the defined VPN requirements. Professional reasoning. Professionals should adopt a layered verification strategy. This begins with a thorough understanding of the VPN service requirements and the intended BGP configuration design. Next, a detailed review of the configuration against this design, focusing on key elements like RDs, RT, and BGP communities, is necessary. This should be followed by targeted operational testing to validate the behavior of route distribution under various scenarios, including normal operation, route changes, and potential failure conditions. Finally, continuous monitoring and periodic re-verification are essential to maintain the integrity and security of the VPN services over time. This systematic and proactive approach minimizes risk and ensures the delivery of reliable and secure network services. Question 5. Process analysis reveals that a service provider needs to deploy a new L3 VPN service utilizing BGP for VPN signaling. The network infrastructure includes existing BGP route reflectors and provider edge (P) routers. What is the most prudent and professionally responsible approach to implement this new L3 VPN service while minimizing disruption to existing services? Option A. Configure the BGP route reflectors first, then the PE routers independently, assuming BGP will automatically handle the VPN signaling without specific L3 VPN configuration validation. Option B. Design and configure the L3 VPN service in a lab environment that closely mirrors the production network, validate its functionality thoroughly, and then implement it in a phased manner on production equipment with continuous monitoring. Option C. Implement the L3 VPN configuration on a single PE router and assume that the configuration will scale correctly to all other PE routers without further testing. Option D. Directly configure the new L3 VPN service on all production PE routers and BGP route reflectors simultaneously to expedite service delivery. The correct answer is D. Directly configure the new L3 VPN service on all production PE routers and BGP route reflectors simultaneously to expedite service delivery. Explanation. Scenario analysis. This scenario presents a common challenge in service provider environments where the need to implement new VPN services, specifically L3 VPNs using BGP, must be balanced against existing network stability and the potential impact on customer traffic. The challenge lies in ensuring that the configuration changes, while necessary for service deployment, do not inadvertently disrupt ongoing operations or violate service level agreements, SLAs, due to misconfiguration or unforeseen interactions between routing protocols. The complexity of BGP route reflection and its interaction with VPN route targets requires meticulous planning and validation to avoid routing black holes or suboptimal path selection. Correct approach analysis. The correct approach involves a phased implementation strategy that prioritizes validation at each step. This begins with a thorough design review, ensuring the proposed L3 VPN architecture aligns with best practices for BGP and MPLS VPNs, including proper route distinguisher (RD) and route target (RT) allocation. The subsequent configuration of BGP route reflectors and the VPN instances on the provider edge (P) routers is then performed in a lab environment that mirrors the production network as closely as possible. This allows for testing of route propagation, VPN membership, and traffic forwarding without impacting live services. Once validated in the lab, a controlled rollout to a subset of production equipment, followed by comprehensive monitoring and verification of traffic flow and routing tables, is crucial. This iterative process of design, lab validation, controlled deployment, and monitoring minimizes risk and ensures the new L3 VPN service is functional and stable before full deployment. This aligns with general IT best practices for change management and risk mitigation, which are implicitly expected in professional service provider operations. Incorrect approaches analysis. Implementing the L3 VPN configuration directly on production routers without prior lab validation is a significant regulatory and ethical failure. It demonstrates a disregard for network stability and customer impact, potentially leading to service outages. This violates the implicit ethical obligation to provide reliable services and could breach contractual SLAs, leading to financial penalties and reputational damage. Configuring BGP route reflectors and PE routers independently without considering their interaction and the overall VPN design is another failure. This siloed approach overlooks the interdependencies within the L3 VPN architecture, increasing the likelihood of routing inconsistencies, black holes, or incorrect traffic paths. This lack of holistic design and validation is unprofessional and increases the risk of service degradation. Deploying the L3 VPN service across the entire production network simultaneously without any staged rollout or monitoring is highly risky. This Big Bang approach amplifies the potential impact of any undetected configuration errors, leading to widespread service disruption. It shows a lack of risk management and a failure to adhere to prudent operational procedures expected in a service provider environment. Professional reasoning. Professionals should adopt a structured and risk-averse approach to network changes. This involves 1. Thorough understanding of the requirements and the chosen technology, L3 VPN, BGP, MPLS. 2. Detailed design and architecture planning, including IP addressing, RD/RT strategy and routing policies. 3. Lab validation of the design and configuration to simulate production behavior. 4. Phased deployment in the production environment, starting with non-critical segments or a small number of devices. 5. Comprehensive monitoring and verification at each stage of the deployment to detect and address issues promptly. 6. Clear rollback procedures in case of unforeseen problems. This systematic process ensures service integrity, minimizes customer impact, and upholds professional standards. Question 6. The control framework reveals a scenario where a service provider is tasked with deploying a new MPLS L3 VPN service for a financial institution that requires strict data segregation and compliance with data residency regulations. The deployment team is under pressure to meet a tight deadline. Which of the following approaches best aligns with the principles of secure and compliant VPN service implementation in this context? Option A. Implement the MPLS L3 VPN using VRF Lite for customer isolation and rely on customer-provided encryption for data confidentiality, with minimal pre-deployment validation to expedite the process. Option B. Deploy the MPLS L3 VPN using a single VRF for all financial clients to simplify management and assume that network segmentation is sufficient, with post-deployment checks only. Option C. Utilize a GRE tunnel over the public internet for the VPN service, as it offers flexibility and rapid deployment, and inform the customer about potential security considerations after the service is live. Option D. Configure the MPLS L3 VPN with distinct VRFs for the financial institution. Utilize strong encryption protocols for data in transit, and conduct thorough pre-deployment testing and post-deployment verification against a defined checklist. The correct answer is A. Implement the MPLS L3 VPN using VRF Lite for customer isolation and rely on customer-provided encryption for data confidentiality, with minimal pre-deployment validation to expedite the process. Explanation. The control framework reveals a common challenge in service provider environments, ensuring consistent and secure VPN service delivery across diverse customer requirements and network segments. The professional challenge lies in balancing the need for rapid service provisioning with the imperative to adhere to stringent security policies and regulatory mandates, particularly concerning data privacy and network integrity. Misconfigurations or deviations from established best practices can lead to security vulnerabilities, service disruptions, and non-compliance, resulting in significant financial and reputational damage. The correct approach emphasizes a layered security model and a robust change management process, aligning with the principles of secure network design and operational excellence expected within the Cisco SPVI domain. This involves leveraging specific VPN technologies and configurations that inherently provide strong isolation and encryption, coupled with rigorous validation steps before and after deployment. Adherence to documented procedures and a thorough understanding of the underlying protocols are paramount for maintaining service integrity and meeting compliance requirements. An incorrect approach that prioritizes speed over security by bypassing validation checks introduces unacceptable risks. This directly violates the principle of least privilege and the need for authenticated and authorized changes, potentially exposing sensitive customer data or allowing unauthorized network access. Another incorrect approach that relies on outdated or insecure VPN protocols fails to meet modern security standards and regulatory expectations for data protection, leaving the service vulnerable to known exploits. A third incorrect approach that neglects proper documentation and auditing hinders troubleshooting, accountability, and future compliance efforts, making it difficult to demonstrate adherence to established controls. Professionals should employ a decision-making framework that prioritizes risk assessment and mitigation. This involves understanding the specific security and compliance requirements for each VPN service, selecting appropriate technologies and configurations that meet those requirements, and implementing a comprehensive testing and validation process. A culture of continuous improvement, regular training, and adherence to established operational procedures are essential for navigating these complex scenarios effectively and ethically. Question 7. The assessment process reveals a service provider is tasked with implementing a new VPN service for a large enterprise customer. The customer requires robust traffic segregation between different departments, strong security for sensitive data, and the ability to scale the service as their business grows. The service provider's network infrastructure is a modern MPLS backbone. Which VPN implementation approach best aligns with these requirements and the service provider's capabilities? Option A. Implement a basic ISEC VPN tunnel directly between the customer's edge routers and the service provider's core routers without utilizing any advanced segmentation features. Option B. Deploy a Layer 2 VPN solution using VLAN to segregate traffic and rely on customer-managed encryption for security. Option C. Utilize a GRE tunnel over the public internet, prioritizing ease of deployment and lower initial cost, with minimal security considerations. Option D. Implement a Layer 3 VPN solution, leveraging MPLS VRFs to provide logical separation of customer traffic and granular routing control. The correct answer is D. Implement a Layer 3 VPN solution, leveraging MPLS VRFs to provide logical separation of customer traffic and granular routing control. Explanation: the assessment process reveals a common challenge in service provider environments, ensuring consistent and secure VPN service delivery across diverse customer requirements and network segments. This scenario is professionally challenging because it requires a deep understanding of VPN technologies, their implementation nuances, and the potential security implications of misconfigurations. The need to balance performance, security, and customer-specific needs without compromising the integrity of the overall service is paramount. Careful judgment is required to select the most appropriate VPN solution that meets both technical and business objectives, while adhering to industry best practices and any applicable service level agreements, SLAs. The correct approach represents best professional practice because it prioritizes a thorough understanding of the customer's specific needs and the network's capabilities before selecting and implementing a VPN solution. This proactive methodology ensures that the chosen VPN technology, in this case, a Layer 3 VPN, is aligned with the customer's traffic patterns, security requirements, and the service provider's operational capabilities. By leveraging a Layer 3 VPN, the service provider can offer robust traffic segregation and routing control, which are critical for enterprise-level VPN services. This approach aligns with the principles of secure and efficient network design, ensuring that the VPN service is not only functional but also resilient and manageable. An incorrect approach that focuses solely on deploying a Layer 2 VPN without a comprehensive assessment would be professionally unacceptable. This failure stems from a lack of understanding of the limitations of Layer 2 VPNs in providing granular traffic control and security segmentation for diverse enterprise traffic. It could lead to broadcast domain issues, increased vulnerability to network attacks, and difficulties in troubleshooting. Ethically, it represents a failure to deliver a service that meets the implicit or explicit requirements for security and performance, potentially violating SLAs and customer trust. Another incorrect approach, implementing a VPN solution without considering the underlying network infrastructure's capacity and scalability, is also professionally unsound. This oversight can lead to performance degradation, service disruptions, and an inability to meet future customer demands. It demonstrates a lack of due diligence in network planning and resource management, which is a fundamental responsibility of a service provider. This failure can result in significant financial and reputational damage. A third incorrect approach, prioritizing cost savings over security and functionality by selecting a less robust or less feature-rich VPN technology, is ethically and professionally problematic. While cost is a factor, it should not come at the expense of delivering a secure and reliable service. This approach can expose the customer and the service provider to significant security risks and operational inefficiencies, ultimately costing more in the long run through incident response and lost business. The professional decision-making process for similar situations should involve a structured approach. 1. Requirements gathering. Thoroughly understand the customer's business needs, technical requirements, security policies, and expected performance metrics. 2. Network assessment. Evaluate the existing network infrastructure's capacity, scalability, and compatibility with potential VPN solutions. 3. Solution evaluation. Compare different VPN technologies, e.g., Layer 2 vs. Layer 3 VPNs, specific protocols, based on their ability to meet the gathered requirements and network constraints. 4. Security considerations. Integrate security best practices and compliance requirements into the solution design. 5. Implementation and testing. Plan and execute a phased implementation with rigorous testing to ensure functionality, performance, and security. 6. Ongoing monitoring and management. Establish processes for continuous monitoring, performance tuning, and incident response. Question 8. The performance metrics show a significant increase in latency and packet loss for multiple MPLS L3 VPN services terminating on a specific provider edge P router. Initial checks indicate that the control plane BGP, MPLS, appears to be up, but user traffic is severely impacted. What is the most appropriate initial troubleshooting step to identify the root cause of this performance degradation? Option A. Verify the BGP neighbor states and the received VPN v4/VPN v6 routes on the affected PE router to ensure correct route propagation and policy application. Option B. Disable the MPLS L3 VPN service on the affected PE router to isolate the problem to the VPN implementation. Option C. Increase the bandwidth of the links connected to the affected PE router to alleviate potential congestion. Option D. Immediately reboot the affected PE router to clear any potential transient software issues. The correct answer is A. Verify the BGP neighbor states and the received VPN v4/VPN v6 routes on the affected PE router to ensure correct route propagation and policy application. Explanation. This scenario presents a common challenge in service provider networks where the implementation of VPN services, specifically MPLS L3 VPNs, must adhere to strict performance and reliability requirements. The professional challenge lies in diagnosing and resolving performance degradation without impacting existing customer traffic or violating service level agreements, SLAs. The chosen approach must balance rapid problem resolution with network stability and adherence to established operational procedures. The correct approach represents best professional practice because it systematically isolates the issue to a specific component, the PE router's BGP configuration, and applies a targeted fix. This minimizes the blast radius of any troubleshooting steps, ensuring that other network functions and customer VPNs remain unaffected. It aligns with the principles of responsible network engineering, prioritizing stability and customer impact mitigation. Furthermore, it implicitly follows the spirit of operational guidelines that emphasize methodical troubleshooting and change control, even if specific regulatory documents are not explicitly cited for this technical scenario. The focus on verifying BGP neighbor states and route advertisements is a fundamental aspect of ensuring L3 VPN control plane integrity, which is critical for service availability. An incorrect approach that involves immediately rebooting the PE router without proper diagnosis is professionally unacceptable. This action is a brute force method that could disrupt multiple services and customer VPNs unnecessarily, leading to significant SLA breaches and customer dissatisfaction. It bypasses established troubleshooting methodologies and risks exacerbating the problem. Ethically, it demonstrates a lack of due diligence and a disregard for the potential impact on customers. Another incorrect approach, such as disabling the entire MPLS L3 VPN service on the affected PE router, is also professionally unsound. While it might stop the immediate performance issue, it results in a complete service outage for all customers utilizing that PE router for their VPNs. This is a drastic measure that should only be considered as a last resort after all other diagnostic and corrective actions have failed. It represents a failure to apply targeted problem solving and a lack of understanding of the granular control available within MPLS L3 VPN configurations. A third incorrect approach, which is to simply increase the bandwidth on the link without investigating the root cause, is also problematic. This is akin to treating a symptom rather than the disease. The performance degradation is likely due to a configuration issue or a control plane problem, not a lack of bandwidth. Applying more bandwidth without addressing the underlying issue is a costly and ineffective solution that does not guarantee long-term stability and may mask the real problem, leading to future, potentially more severe, issues. Demonstrates a lack of analytical rigor and a failure to adhere to sound engineering principles. The professional decision-making process for similar situations should involve a structured approach. 1. Define the problem clearly, including symptoms and scope. 2. Gather relevant data, performance metrics, logs, configuration. 3. Formulate hypotheses about the root cause. 4. Test hypotheses systematically, prioritizing non-disruptive methods. 5. Implement the most targeted and least impactful solution. 6. Verify the resolution and monitor for recurrence. 7. Document the process and findings. Question 9. Governance review demonstrates a potential gap in the implementation of BGP flow spec for DDoS mitigation within a critical customer-facing VPN service, leading to increased vulnerability. The business unit is pushing for immediate resolution to avoid potential service disruption and reputational damage. What is the most appropriate course of action to address this identified security gap while adhering to service provider best practices and regulatory compliance? Option A. Acknowledge the governance review findings but continue with the current configuration, assuming the risk is low and no immediate threat is present, to avoid disrupting ongoing operations. Option B. Initiate a phased implementation plan that includes thorough risk assessment, detailed design and validation in a lab environment, followed by a controlled rollout with continuous monitoring. Option C. Roll back the entire VPN service to a previous stable configuration to eliminate the immediate risk, and postpone any remediation efforts until a later, less critical period. Option D. Immediately deploy BGP flow spec configuration to all affected network devices in the production environment to mitigate the identified vulnerability without delay. The correct answer is D. Immediately deploy BGP flow spec configuration to all affected network devices in the production environment to mitigate the identified vulnerability without delay. Explanation. Scenario analysis. This scenario presents a common challenge in service provider environments where the rapid deployment of new VPN services, driven by business demands, can outpace the thoroughness of security and compliance validation. The challenge lies in balancing agility with the imperative to adhere to established security policies and regulatory mandates. A governance review highlighting a potential gap in the implementation of a critical security feature like BGP flow spec for DDoS mitigation creates a direct conflict between operational efficiency and risk management. The pressure to quickly address the identified vulnerability while ensuring no new risks are introduced requires careful consideration of technical feasibility, operational impact, and adherence to the SPVI framework's implicit and explicit security best practices. Correct approach analysis. The correct approach involves a phased implementation strategy that prioritizes immediate mitigation while ensuring long-term compliance and security. This begins with a thorough risk assessment to understand the potential impact of the identified gap and the urgency of remediation. Subsequently, a detailed design and validation phase is crucial to ensure that any proposed solution, such as the implementation of BGP flow spec, aligns with existing security policies, operational procedures, and the principles outlined in the SPVI curriculum. This includes rigorous testing in a lab environment to confirm functionality, performance, and security efficacy before deployment into the production network. The final step of a controlled, phased rollout with continuous monitoring allows for early detection of issues and minimizes disruption. This approach represents best professional practice because it systematically addresses the identified risk, adheres to a structured implementation methodology, and prioritizes the integrity and security of the service provider's network, aligning with the core tenets of secure VPN service implementation as taught in the SPVI. Incorrect approaches analysis. Implementing BGP flow spec immediately in the production environment without prior design, validation, or risk assessment is a significant regulatory and ethical failure. This bypasses essential security controls and testing phases, directly violating the principle of controlled change management and potentially introducing unforeseen vulnerabilities or service disruptions. It demonstrates a disregard for the established governance framework and the SPVI emphasis on secure, reliable network operations. Rolling back the entire VPN service to a previous state without a clear understanding of the root cause or a plan for remediation is also professionally unacceptable. While it might temporarily remove the perceived risk, it fails to address the underlying issue and demonstrates a lack of problem-solving capability. This approach ignores the business need for the service and shows an inability to manage and resolve technical challenges effectively, potentially leading to prolonged service outages and customer dissatisfaction. Ignoring the governance review findings and continuing with the current configuration, assuming no immediate threat, is a critical ethical and regulatory failure. This constitutes negligence and a deliberate disregard for established security policies and risk management protocols. It exposes the service provider to significant security threats and potential regulatory penalties, undermining the trust placed in the organization to manage its network securely. Professional reasoning. Professionals facing such a situation should adopt a structured problem-solving approach. First, Acknowledge and thoroughly understand the findings of the governance review. Second, conduct a comprehensive risk assessment to prioritize the identified gap based on its potential impact. Third, engage in a detailed design and validation process for any proposed solution, ensuring it aligns with security policies and best practices. Fourth, plan and execute a controlled, phased implementation with robust monitoring. Finally, document all actions taken and lessons learned to continuously improve the governance and operational processes. This systematic approach ensures that business needs are met while maintaining the highest standards of security and compliance. Question 10. The audit findings indicate that the service provider's risk assessment process for customer VPN services lacks a structured methodology for identifying and prioritizing potential threats to sensitive customer data. Which of the following approaches best addresses this deficiency while adhering to the principles of responsible data stewardship and regulatory compliance? Option A. Rely on the inherent security features of the VPN technology itself to mitigate risks without further assessment. Option B. Implement a formal risk assessment framework that includes threat modeling, vulnerability analysis, and impact assessment specific to customer VPN deployments, prioritizing mitigation efforts based on the criticality of identified risks. Option C. Focus on optimizing network performance and reducing latency for VPN traffic, assuming security is adequately addressed by default configurations. Option D. Conduct a post-incident review of any past data breaches to identify lessons learned and update security policies accordingly. The correct answer is B. Implement a formal risk assessment framework that includes threat modeling, vulnerability analysis, and impact assessment specific to customer VPN deployments, prioritizing mitigation efforts based on the criticality of identified risks. Explanation. The audit findings indicate a potential vulnerability in the service provider's VPN service implementation, specifically concerning the risk assessment process for customer data protection. This scenario is professionally challenging because it requires balancing the technical requirements of VPN service delivery with the imperative to safeguard sensitive customer information, all within the bounds of regulatory compliance. The service provider must demonstrate a robust and proactive approach to identifying, evaluating, and mitigating risks associated with VPN configurations and customer data flows. The correct approach involves a comprehensive risk assessment that systematically identifies potential threats to customer data confidentiality, integrity, and availability within the VPN service. This includes evaluating the likelihood and impact of these threats, considering factors such as unauthorized access, data leakage, misconfigurations, and compliance with relevant data protection regulations. By prioritizing risks based on their potential severity and implementing appropriate controls, the service provider ensures that customer data is adequately protected, thereby upholding its contractual obligations and regulatory responsibilities. This aligns with best professional practices by demonstrating due diligence and a commitment to security and privacy. An incorrect approach that focuses solely on meeting minimum technical specifications without a thorough risk assessment fails to address the potential for harm to customers. This could lead to regulatory noncompliance, reputational damage, and legal liabilities. For instance, neglecting to assess the risk of data exfiltration through misconfigured VPN tunnels or inadequate access controls would be a significant ethical and regulatory failure, as it directly jeopardizes customer data. Another incorrect approach might involve relying on generic security measures without tailoring them to the specific risks inherent in the service provider's VPN offerings and customer use cases. This lack of specificity means that critical vulnerabilities might be overlooked, leaving customer data exposed. Professionals should adopt a structured risk management framework. This involves establishing clear policies and procedures for risk assessment, conducting regular reviews and updates, and ensuring that all personnel involved understand their roles and responsibilities. The decision-making process should prioritize the protection of customer data, informed by a deep understanding of the service provider's technical environment, the types of data being handled, and the applicable regulatory landscape. When faced with audit findings, the immediate step should be to initiate a detailed investigation to understand the root cause of the identified risks and to develop a remediation plan that addresses the findings effectively and demonstrably. Question 11. The evaluation methodology shows a service provider is tasked with implementing a new secure VPN service for a financial institution. The client has requested a rapid deployment to meet a critical business deadline. The service provider's technical team proposes a configuration that leverages advanced VPN features for optimal performance, but acknowledges that a full, independent security audit of the specific implementation details against the jurisdiction's data privacy and telecommunications security regulations might delay the deployment by 2 weeks. The client is strongly advocating for the faster deployment, suggesting that the vendor's compliance certification should be sufficient. What is the most professionally responsible approach to ensure both client needs and regulatory adherence are met? Option A. Advise the client that the regulatory framework mandates a comprehensive pre-deployment audit of all security configurations and propose a revised timeline that accommodates this essential step. Option B. Proceed with the deployment as proposed, relying on the vendor's compliance certifications and prioritizing the client's deadline, with a commitment to conduct a post-deployment audit. Option C. Deploy a basic VPN configuration that is known to meet all regulatory requirements quickly, and then offer the advanced features as a post-deployment upgrade once the audit is complete. Option D. Implement the advanced VPN features as requested, but conduct a focused, expedited validation of critical security controls against the jurisdiction's specific regulatory requirements before full activation, even if it means a slight delay. The correct answer is B. Proceed with the deployment as proposed, relying on the vendor's compliance certifications and prioritizing the client's deadline, with a commitment to conduct a post-deployment audit. Explanation. The evaluation methodology shows a critical juncture in implementing a new VPN service for a large enterprise client. The challenge lies in balancing the client's demand for rapid deployment with the inherent security and compliance requirements mandated by the regulatory framework governing telecommunications and data privacy within the specified jurisdiction. Specifically, the client is pushing for a simplified configuration to accelerate service activation, which could inadvertently bypass essential security controls and auditing mechanisms. This scenario is professionally challenging because a failure to adhere to the regulatory framework can lead to significant financial penalties, reputational damage, and a breach of client trust, while an overly cautious approach might lead to project delays and client dissatisfaction. The correct approach represents best professional practice because it prioritizes a comprehensive risk assessment and validation process before full deployment. This involves meticulously verifying that all implemented VPN configurations, including encryption protocols, authentication mechanisms, and access control lists, strictly adhere to the established regulatory standards. This proactive validation ensures that the service not only meets the client's functional requirements, but also maintains the highest level of security and compliance, thereby mitigating potential risks and demonstrating professional diligence. This aligns with the ethical obligation to provide secure and compliant services. An incorrect approach that bypasses security validation to meet an aggressive timeline is professionally unacceptable. This failure constitutes a direct violation of the regulatory framework's mandates for secure network infrastructure and data protection. Such an action would expose the client to significant security vulnerabilities, potentially leading to data breaches and non-compliance with data privacy laws. Ethically, it represents a dereliction of professional duty to safeguard client information and infrastructure. Another incorrect approach that relies solely on vendor default configurations without independent verification is also problematic. While vendors often adhere to general security best practices, their default settings may not fully align with the specific, stringent requirements of the governing jurisdiction or the unique security posture of the client. This oversight can lead to compliance gaps and security weaknesses that are not immediately apparent, creating a false sense of security. A third incorrect approach that prioritizes cost-effectiveness over robust security features, such as opting for less secure encryption algorithms or weaker authentication methods to reduce licensing or hardware costs, is equally unacceptable. This decision directly contravenes the regulatory emphasis on employing strong security measures to protect sensitive data. It demonstrates a failure to understand and apply the principles of secure network design, prioritizing financial gain over the client's security and regulatory obligations. The professional decision-making process for similar situations should involve a structured approach. First, thoroughly understanding the client's requirements and the applicable regulatory framework. Second, conducting a detailed risk assessment to identify potential security and compliance vulnerabilities. Third, designing a solution that not only meets functional needs, but also demonstrably satisfies all regulatory mandates. Fourth, implementing rigorous testing and validation procedures to confirm compliance and security before deployment. Finally, maintaining clear and transparent communication with the client regarding security and compliance considerations throughout the project lifecycle. Question 12. The risk matrix shows a high probability of customer impact if new VPN configuration parameters are deployed without adequate validation. Considering the need to minimize service disruption and maintain customer trust, which deployment strategy best aligns with professional best practices for implementing these changes across a large service provider network? Option A. Postpone the deployment of the new VPN configuration parameters indefinitely until a completely risk-free implementation method can be identified, which may take an extended period. Option B. Apply the new VPN configuration parameters to all customer VPNs immediately, relying on the inherent stability of the existing network infrastructure to absorb any potential issues. Option C. Deploy the new VPN configuration parameters to all customer VPNs simultaneously to ensure immediate consistency and avoid any potential for configuration drift between different customer groups. Option D. Implement the new VPN configuration parameters on a small subset of non-critical customer VPNs first, closely monitoring for any anomalies, and then proceed with a phased rollout to other customer segments based on successful validation. The correct answer is D. Implement the new VPN configuration parameters on a small subset of non-critical customer VPNs first, closely monitoring for any anomalies, and then proceed with a phased rollout to other customer segments based on successful validation. Explanation. This scenario presents a common challenge in service provider environments where the implementation of VPN services must balance performance, security, and adherence to established operational procedures. The risk matrix highlights potential disruptions to customer connectivity and data integrity, underscoring the critical need for a robust and well-tested approach to configuration changes. The professional challenge lies in selecting a method that minimizes risk while ensuring efficient deployment and compliance with internal change management policies, which are implicitly governed by the need to maintain service availability and customer trust, core tenets of responsible service provision. The correct approach represents best professional practice because it prioritizes a controlled and validated deployment. By performing a staged rollout, starting with a limited set of non-critical customer VPNs, the service provider can meticulously monitor performance and identify any unforeseen issues before impacting a wider customer base. This iterative validation process aligns with industry best practices for network change management, aiming to prevent widespread service degradation or outages. It demonstrates a commitment to service reliability and customer satisfaction, which are paramount in the competitive VPN service market. Furthermore, this method allows for timely rollback if issues are detected, mitigating potential financial and reputational damage. An incorrect approach that involves immediate deployment to all customer VPNs without prior testing is professionally unacceptable. This bypasses essential validation steps, significantly increasing the risk of a widespread service disruption. Such an action would violate the implicit ethical obligation to provide reliable service and could lead to significant customer dissatisfaction, contract breaches, and potential regulatory scrutiny for failing to meet service-level agreements. Another incorrect approach, which is to delay the deployment indefinitely due to fear of any potential risk, is also professionally unsound. While risk aversion is important, complete inaction prevents the adoption of potentially beneficial new features or security enhancements. This can lead to a competitive disadvantage and may eventually result in a failure to meet evolving customer demands or security standards, indirectly impacting service quality and customer retention. A further incorrect approach, such as implementing the changes without any form of documentation or rollback plan, is a direct contravention of sound operational principles. This lack of preparedness makes troubleshooting and recovery extremely difficult in the event of a problem, leading to prolonged downtime and increased operational costs. It demonstrates a disregard for systematic problem solving and a failure to adhere to basic IT service management (ITSM) principles, which are foundational for maintaining a stable and secure network infrastructure. The professional decision-making process for similar situations should involve a thorough risk assessment, followed by the development of a phased deployment strategy. This strategy should include clear testing criteria, monitoring plans, and a well-defined rollback procedure. Collaboration with relevant teams, e.g., network operations, customer support, is crucial to ensure all aspects of the deployment are considered. Continuous evaluation of the implemented changes and adherence to established change management frameworks are essential for maintaining service integrity and customer trust. Question 13. System analysis indicates a service provider is tasked with deploying a new high-security VPN service for a critical enterprise customer. The customer has specified stringent requirements for data confidentiality and integrity, and has emphasized the need for a robust and auditable implementation process. The technical team has identified several potential methods for configuring the VPN, ranging from a rapid, script-driven deployment to a more deliberate, manually verified configuration. Evaluating these options, which approach best aligns with professional best practices for implementing such a sensitive service. Option A. Manually configure each VPN tunnel endpoint, meticulously verifying each parameter against the customer's requirements and internal security policies, followed by a comprehensive end-to-end testing phase. Option B. Deploy the VPN service with default security settings, and then rely on the customer's internal security team to identify and report any configuration issues. Option C. Implement the VPN service using a pre-tested automated script that incorporates all customer-specified security parameters, and then perform a post-deployment functional and security audit. Option D. Utilize a combination of automated configuration for basic parameters and manual adjustments for advanced security features, with a light functional check before service activation. The correct answer is C. Implement the VPN service using a pre-tested automated script that incorporates all customer-specified security parameters, and then perform a post-deployment functional and security audit. Explanation. This scenario presents a common challenge in service provider environments, balancing the need for rapid service deployment with the imperative of maintaining robust security and compliance. The professional challenge lies in identifying the most effective and compliant method for implementing a new VPN service that meets stringent customer requirements without introducing vulnerabilities or violating established protocols. The chosen approach must not only be technically sound, but also align with the implicit regulatory expectations of secure data transmission and service integrity, even if specific regulations are not explicitly detailed in the exam syllabus. The principles of secure network design and service delivery are universally applicable in a professional context. The correct approach represents best professional practice because it prioritizes a structured, documented, and validated implementation process. This involves thorough planning, adherence to established design principles, and rigorous testing. Such a methodical approach minimizes the risk of misconfiguration, security breaches, and service disruptions. It ensures that the VPN service is not only functional but also secure, reliable, and auditable, thereby meeting customer expectations and upholding the service provider's reputation. This aligns with the general professional obligation to deliver services that are fit for purpose and meet industry standards for security and performance. An incorrect approach that bypasses essential validation steps, such as comprehensive testing or peer review, represents a significant regulatory and ethical failure. It introduces an unacceptable level of risk, potentially leading to data compromise, service outages, or noncompliance with customer security mandates. Such shortcuts undermine the integrity of the service and the trust placed in the service provider. Failing to document changes or adhere to established change management procedures also constitutes a failure, as it hinders troubleshooting, auditing, and future maintenance. It can violate internal policies that often mirror regulatory requirements for accountability. The professional decision-making process for similar situations should involve a risk-based assessment. Before implementing any new service or significant change, professionals must 1. Understand the requirements thoroughly, including security and compliance aspects. 2. Evaluate potential implementation methods against these requirements and known best practices. 3. Identify and quantify the risks associated with each method. 4. Select the method that offers the best balance of efficiency, security, and compliance, with a strong emphasis on minimizing risk. 5. Ensure that the chosen method includes adequate planning, testing, documentation, and change control. Question 14. Compliance review shows that a service provider has recently implemented several new MPLS VPN services for enterprise clients. During a post-implementation audit, it was noted that while VRFs were correctly defined on the provider edge, routers and basic BGP peering was established, there is a concern regarding the precise enforcement of traffic isolation between these newly provisioned VPNs. The audit team suspects that the configuration of BGP extended communities and route targets, which are critical for VPN membership and route import/export policies, may not have been exhaustively verified for each individual VPN instance. This could potentially lead to unintended route propagation and compromise the security and privacy of customer data. Which of the following approaches best addresses this compliance concern and ensures the integrity of the implemented VPN services? Option A. Conduct a thorough review of the BGP configuration on all PE routers, specifically verifying the assignment and matching of route targets and extended communities for each VPN's route distinguisher and VRF import/export policies. Option B. Perform a high-level check of the VRF definitions and BGP neighbor states, assuming that if BGP is up and VRFs are present, the VPNs are correctly isolated. Option C. Rely on the default BGP route selection process and assume that standard VRF configurations inherently provide sufficient isolation for MPLS VPNs. Option D. Focus on verifying the overall bandwidth utilization and latency metrics for the new VPN services, as these are the primary indicators of successful service delivery. The correct answer is A. Conduct a thorough review of the BGP configuration on all PE routers, specifically verifying the assignment and matching of route targets and extended communities for each VPN's route distinguisher and VRF import/export policies. Explanation. This scenario presents a professional challenge in ensuring the integrity and security of VPN services within a service provider context, specifically concerning the implementation of BGP extensions for VPNs. The core difficulty lies in balancing the need for efficient routing and traffic engineering with the imperative to maintain strict isolation between different customer VPNs, a fundamental requirement for service provider offerings. Misconfigurations can lead to data leakage, unauthorized access, or service disruption, all of which have significant regulatory and contractual implications. The correct approach, which involves meticulously verifying the configuration of BGP extended communities and route targets on PE routers to ensure proper VPN membership and traffic segregation, represents best professional practice. This aligns with the principles of secure network design and operation, which are implicitly or explicitly mandated by various industry standards and service-level agreements, SLAs, that service providers must adhere to. By confirming that route targets are correctly assigned and that extended communities are used to enforce VRF membership, network engineers ensure that routes advertised within one VPN are not inadvertently imported into another, thereby upholding the principle of customer data isolation. This proactive verification is crucial for preventing security breaches and maintaining customer trust, which are paramount in the service provider industry. An incorrect approach that overlooks the granular configuration of BGP extended communities and route targets, perhaps by relying solely on basic VRF definitions, fails to adequately address the complexities of VPN routing. This oversight can lead to route leaks, where traffic intended for one VPN is accessible or routed to another, constituting a significant security and privacy failure. Such a failure would violate the implicit contractual obligation to provide secure and isolated VPN services and could contravene data protection regulations if customer data is compromised. Another incorrect approach might involve assuming that default BGP behavior or standard VRF configurations are sufficient without explicit verification of the route target and extended community settings. This assumption is dangerous as it neglects the specific mechanisms designed to enforce VPN isolation. In a service provider environment, where multiple customers share the same infrastructure, such a lapse in verification can result in a direct breach of customer SLAs and potentially lead to regulatory penalties related to service availability and data security. A third incorrect approach could be to prioritize rapid deployment over thorough configuration validation, especially when dealing with new VPN service rollouts. While speed is often a business imperative, it should never come at the expense of security and compliance. Failing to meticulously check the BGP extended communities and route targets during deployment means that potential vulnerabilities are introduced from the outset. This not only increases the risk of immediate security incidents, but also creates a more complex and time-consuming remediation process later, potentially impacting customer satisfaction and incurring financial penalties. The professional decision-making process for similar situations should involve a layered approach to verification. First, understand the specific requirements of the VPN service and the expected traffic flow. Second, consult the relevant design documentation and configuration templates. Third, perform detailed configuration checks on all relevant network devices, focusing on the specific BGP attributes that enforce VPN isolation, such as route targets and extended communities. Fourth, conduct thorough testing, including traffic path verification and isolation tests, to confirm that the configuration functions as intended. Finally, maintain comprehensive documentation of the configuration and verification process for auditing and future reference. This systematic approach ensures that security and compliance are integrated into the network deployment lifecycle, rather than being an afterthought. Question 15. Strategic planning requires a methodical approach to implementing new VPN services to ensure both security and performance. A service provider is tasked with deploying a complex VPN solution for a critical enterprise client with specific latency and data integrity requirements. Given the tight deadline, what is the most professionally responsible approach to ensure successful implementation and minimize operational risk? Option A. Prioritize the customer's immediate request by deploying the VPN service without extensive pre-production testing to meet the deadline. Option B. Configure and deploy the VPN service directly into the live production network without any prior testing in a lab environment. Option C. Deploy the VPN service in stages, with thorough testing and validation conducted after each stage before proceeding to the next. Option D. Implement the entire VPN service configuration in the production environment, and then perform post-deployment validation. The correct answer is D. Implement the entire VPN service configuration in the production environment, and then perform post-deployment validation. Explanation. Scenario analysis. This scenario presents a common implementation challenge in service provider networks where a new VPN service needs to be deployed with stringent security and performance requirements. The challenge lies in balancing the need for rapid deployment with the imperative to adhere to established best practices and potential regulatory considerations for data privacy and service availability. Even if not explicitly stated as a legal mandate in the SPVI context, the principles of robust design and operational integrity are paramount. The pressure to deliver quickly can lead to shortcuts that compromise long-term stability and security. Correct approach analysis. The correct approach emphasizes a phased implementation with thorough testing at each stage. This aligns with best professional practices for network engineering, particularly in service provider environments. It ensures that each component of the VPN service, from the underlying infrastructure to the customer-facing configurations, is validated before proceeding. This methodical approach minimizes the risk of introducing errors that could impact service availability, security, or performance for existing or new customers. It also allows for early detection and remediation of issues, reducing the overall time and cost associated with troubleshooting. In the context of SPVI, this reflects a commitment to building reliable and secure VPN services, which is a core objective of the certification. Incorrect approaches analysis. Implementing the entire VPN service in a single, unverified deployment is a significant professional failure. It bypasses critical validation steps, dramatically increasing the risk of widespread service disruption or security vulnerabilities. This approach disregards the principle of incremental deployment and testing, which is fundamental to network stability. It could lead to a complete service outage, impacting multiple customers and potentially causing significant financial and reputational damage. Deploying the VPN service without any form of pre-production testing, even in a lab environment, is also professionally unacceptable. This demonstrates a lack of due diligence and a disregard for the potential consequences of untested configurations. It assumes that configurations will work perfectly in a live production environment, which is rarely the case. This approach significantly elevates the risk of introducing bugs or misconfigurations that could compromise the integrity of the VPN service. Focusing solely on the customer's immediate request without considering the broader network impact or potential security implications is another flawed approach. While customer satisfaction is important, it should not come at the expense of network stability and security. This approach can lead to the deployment of a solution that, while meeting the immediate need, creates future problems or introduces security risks that were not adequately assessed. It lacks a holistic view of network operations and security posture. Professional reasoning. Professionals should adopt a structured, risk-aware approach to network implementation. This involves 1. Understanding requirements, clearly defining the technical, security, and performance requirements of the VPN service. 2. Design and planning, developing a detailed design that considers scalability, security, and resilience. 3. Phased implementation, breaking down the deployment into manageable stages with clear objectives and validation points for each stage. 4. Rigorous testing, conducting comprehensive testing in a lab environment and then in a controlled production rollout, simulating real-world traffic and failure scenarios. 5. Monitoring and validation, continuously monitoring the service after deployment to ensure it meets performance and security objectives. 6. Documentation, maintaining thorough documentation of the design, implementation, and configuration. This systematic process minimizes risk, ensures service quality, and upholds professional standards in network service delivery. Question 16. The audit findings indicate a potential for inter-customer traffic leakage within the MPLS VPN infrastructure due to an oversight in route distinguisher and route target configuration. Which of the following approaches best addresses this critical security and isolation vulnerability? Option A. Implement a comprehensive review and correction of VRF route distinguisher and route target configurations across all affected customer VPNs to ensure strict route separation. Option B. Deploy additional firewalls at the edge of the MPLS network to filter traffic between customer prefixes. Option C. Disable advanced VPN features like BGP VPN to simplify the configuration and reduce the likelihood of errors. Option D. Increase the overall bandwidth allocation for the MPLS network to mitigate potential congestion that might exacerbate traffic leakage. The correct answer is A. Implement a comprehensive review and correction of VRF route distinguisher and route target configurations across all affected customer VPNs to ensure strict route separation. Explanation. The audit findings indicate a potential misconfiguration in the implementation of a service provider VPN service, specifically concerning the security and isolation of customer traffic. This scenario is professionally challenging because it directly impacts customer trust, service integrity, and adherence to service-level agreements (SLAs), which are critical in the service provider domain. The complexity arises from the interconnected nature of VPN technologies and the potential for subtle errors to have significant security implications. Careful judgment is required to identify the root cause and implement a robust solution that not only rectifies the immediate issue, but also prevents recurrence, all while minimizing service disruption. The correct approach, focusing on verifying and enforcing strict isolation mechanisms between VPN instances, represents best professional practice. This aligns with the fundamental principles of VPN service delivery, which mandate that customer traffic remains private and segregated. In the context of the 300-515 SPVI exam, this translates to ensuring that technologies like VRF-like and MPLS VPN, specifically BGP-based VPNs with route distinguisher and route target manipulation, or other isolation techniques, are correctly configured and functioning as intended. Adherence to these principles is implicitly governed by industry best practices and the implicit contractual obligations service providers have to their customers regarding data confidentiality and integrity. While specific regulatory frameworks for VPN implementation are not explicitly detailed in the SPVI exam syllabus as a primary focus, the operational and security requirements are paramount. An incorrect approach that involves simply increasing bandwidth or CoS without addressing the underlying isolation issue is professionally unacceptable. This fails to address the core problem of potential traffic leakage or unauthorized access between VPNs, which is a severe security vulnerability. Ethically, This constitutes a failure to uphold the service provider's responsibility to secure customer data. Another incorrect approach, such as disabling certain VPN features to simplify configuration, is also professionally unacceptable. This would likely violate customer requirements and SLAs, leading to service degradation and potential contractual breaches. It demonstrates a lack of understanding of the fundamental purpose of VPN services. A third incorrect approach, focusing solely on external network security measures without examining the internal VPN segmentation, is also flawed. While external security is important, it does not mitigate risks arising from misconfigurations within the VPN infrastructure itself, leaving the core problem unaddressed and customer data potentially exposed. The professional decision-making process for similar situations should involve a systematic approach. First, thoroughly understand the audit findings and their potential impact. Second, consult the relevant technical documentation and design principles for the specific VPN technologies in use. Third, perform detailed verification of the configuration against established best practices for traffic isolation and security. Fourth, prioritize solutions that address the root cause of the security or isolation concern while minimizing service impact. Finally, implement changes in a controlled manner, followed by rigorous testing and validation to confirm the issue is resolved and no new problems have been introduced. Question 17. Assessment of the most appropriate VPN implementation strategy for a new enterprise customer requiring secure, isolated Layer 3 connectivity across multiple sites, considering scalability and adherence to data isolation principles. Option A. Establish GRE tunnels over the public internet for each customer site. Option B. Utilize a Layer 2 VPN technology like VPLS without additional segmentation. Option C. Implement a Layer 3 VPN using MPLS with BGP as the VPN routing protocol. Option D. Deploy a full mesh of ISEC tunnels between customer edge devices and the service provider's core. Correct answer is C. Implement a Layer 3 VPN using MPLS with BGP as the VPN routing protocol. Explanation. Scenario analysis. This scenario presents a common implementation challenge in service provider networks where a new customer requires a VPN service with specific traffic isolation and security requirements. Challenge lies in selecting the most appropriate VPN technology that meets these needs while adhering to best practices for scalability, manageability, and security. The service provider must balance the customer's immediate needs with the long-term operational implications of the chosen solution. Misinterpreting the requirements or selecting an overly complex or insecure solution can lead to service disruptions, security breaches, and customer dissatisfaction, all of which have significant business and potential regulatory implications if data privacy or service availability is compromised. Correct approach analysis. Implementing a Layer 3 VPN using MPLS with BGP as the VPN routing protocol is the best professional practice in this scenario. This approach leverages the robust and scalable nature of MPLS for efficient traffic forwarding and isolation. BGP, when used as the VPN routing protocol, e.g., MPBGP with VPNv4/VPNv6 address families, provides the necessary control plane mechanisms to ensure strict traffic separation between different VPN customers. Each customer's routes are advertised only to their respective VPNs, preventing inter-customer traffic leakage. This solution is highly scalable, allowing for the addition of numerous VPNs without significant network redesign. It also aligns with industry standards for service provider VPNs, ensuring interoperability and manageability. From a regulatory perspective, this approach provides a strong foundation for meeting data isolation requirements, which are often mandated by data protection regulations. Incorrect approach is analysis. Using a Layer 2 VPN technology like VPLS without proper segmentation mechanisms would be a regulatory and ethical failure. While VPLS provides Layer 2 connectivity, it can be more challenging to enforce strict traffic isolation at the IP layer without additional security measures. If not configured meticulously, it could inadvertently allow for inter-customer traffic to be forwarded within the same VPLS instance, violating data privacy and isolation mandates. Implementing a GRE tunnel over the public internet for each customer would be a significant security and scalability failure. GRE tunnels offer minimal inherent security, no encryption by default, and do not provide robust traffic isolation between different customers sharing the same underlying infrastructure. This approach is highly unmanageable as the number of customers grows, and it would likely fail to meet any regulatory requirements for secure and isolated data transmission. Deploying a full mesh of ISEC tunnels between the customer edge devices and the service provider's core would be operationally complex and unscalable. While ISEC provides strong encryption and authentication, managing a full mesh of tunnels for a large customer base is extremely difficult, prone to configuration errors, and does not inherently provide the efficient traffic engineering and isolation benefits of MPLS. This complexity increases the risk of misconfiguration, which could lead to security vulnerabilities or service outages, potentially violating service-level agreements and regulatory compliance. Professional reasoning. Professionals should approach such implementation challenges by first thoroughly understanding the customer's technical and business requirements, paying close attention to any stated or implied security and isolation needs. This understanding should then be mapped against the capabilities and limitations of available VPN technologies. The decision-making process should prioritize solutions that offer scalability, manageability, and robust security features, aligning with industry best practices and relevant regulatory frameworks. A phased approach, starting with a pilot or proof of concept for complex deployments, can help mitigate risks. Continuous monitoring and auditing of the VPN infrastructure are crucial to ensure ongoing compliance and security. Question 18. Comparative studies suggest that network engineers implementing VPN services for financial institutions face ethical dilemmas when clients request expedited deployment that might bypass established security protocols. If a network engineer is tasked with configuring a new VPN for a major financial client and receives the client's pre-shared key and certificate information via email, what is the most professional and ethically sound course of action to ensure the secure and compliant implementation of the VPN service? Option A. Inform the client that the current method of credential transmission is insecure and propose a secure alternative for data exchange, such as a secure file transfer protocol, SFTP, or a secure portal, before proceeding with any configuration. Option B. Encrypt the sensitive credentials using a strong encryption method, then transmit them securely to the client for verification and subsequent use in the VPN configuration. Option C. Immediately configure the VPN using the provided credentials, as the client's request for expedited deployment implies a critical need. Option D. Forward the original email containing the sensitive credentials directly to the client's designated technical contact for their review and confirmation. The correct answer is B. Encrypt the sensitive credentials using a strong encryption method, then transmit them securely to the client for verification and subsequent use in the VPN configuration. Explanation. Scenario analysis. This scenario presents a professional challenge where a network engineer is tasked with implementing a critical VPN service for a financial institution. The challenge lies in balancing the urgency of the client's request with the imperative to adhere to established security protocols and best practices, particularly concerning the handling of sensitive configuration data. The engineer must navigate potential pressure from the client to expedite the process, which could lead to shortcuts that compromise security. The ethical dilemma arises from the potential for unauthorized access or data breaches if security measures are bypassed, impacting not only the client, but also the integrity of the service provider's operations and reputation. Correct approach analysis. The correct approach involves meticulously following the established security policy for VPN configuration, which includes encrypting sensitive credentials before transmission and verifying the integrity of the configuration file through a secure channel. This aligns with the principles of data confidentiality and integrity, fundamental to secure network services. Adhering to these protocols ensures that sensitive information, such as pre-shared keys or certificates, is protected from interception and tampering during the transfer process. This demonstrates professional responsibility, upholds the service provider's commitment to security, and mitigates the risk of a security incident, thereby protecting the client's assets and maintaining trust. This approach is directly supported by industry best practices and likely mandated by internal service provider policies designed to comply with general cybersecurity frameworks and potentially specific regulations governing financial data protection. Incorrect approaches analysis. Transmitting the VPN configuration file containing unencrypted sensitive credentials via email represents a significant regulatory and ethical failure. Email is inherently insecure and not designed for the transmission of sensitive data. This action directly violates the principle of data confidentiality, exposing the client's financial data to potential interception and unauthorized access. It also breaches the duty of care owed to the client and the service provider's own security policies, which would undoubtedly prohibit such a practice. Sending the configuration file via a standard, unencrypted file transfer protocol, FTP, also constitutes a regulatory and ethical failure. Similar to email, standard FTP does not provide encryption, leaving sensitive credentials vulnerable to eavesdropping during transit. This bypasses established security measures and demonstrates a disregard for data protection, increasing the risk of a security breach and potential financial losses for the client. Providing the client with direct, unauthenticated access to the VPN configuration file on a shared network drive, even if password protected, is also professionally unacceptable. This approach lacks the necessary security controls for sensitive data transfer. The password protection might be weak, and the shared drive itself could be compromised. This method fails to ensure the confidentiality and integrity of the configuration data, exposing it to unauthorized access and modification, which is a direct contravention of security best practices and ethical obligations. Professional reasoning. Professionals in this field must adopt a decision-making process that prioritizes security and compliance. This involves 1. Understanding and strictly adhering to all relevant security policies and procedures. 2. Identifying and assessing potential risks associated with any proposed action, especially concerning sensitive data. 3. Prioritizing secure methods for data transmission and storage, utilizing encryption and secure protocols. 4. Communicating any potential security concerns or deviations from policy to appropriate stakeholders, including management and the client, to ensure transparency and informed decision-making. 5. Documenting all actions taken and decisions made, particularly those involving security configurations. This systematic approach ensures that client needs are met without compromising the security and integrity of the network services provided. Question 19. Quality control measures reveal that a network engineer, while troubleshooting a performance degradation issue on a customer's MPLS VPN, accessed and reviewed packet payloads from the customer's traffic without explicit prior authorization. The engineer claims this was necessary to quickly identify the root cause of the latency. What is the most appropriate course of action for the service provider in this situation? Option A. Acknowledge the engineer's initiative in resolving the performance issue and provide a verbal commendation, while reminding them to follow standard operating procedures for future troubleshooting. Option B. Immediately terminate the engineer's access to customer VPN traffic and initiate a formal investigation into the incident, reviewing the service provider's data access policies and providing additional training on data privacy protocols. Option C. Issue a formal warning to the engineer for violating data privacy policies and require them to undergo mandatory retraining on customer data handling and VPN security. Option D. Review the engineer's logs to confirm the extent of the data accessed, and if deemed minor, consider it an acceptable deviation from policy given the urgency of the customer's issue. The correct answer is B. Immediately terminate the engineer's access to customer VPN traffic and initiate a formal investigation into the incident, reviewing the service provider's data access policies and providing additional training on data privacy protocols. Explanation. The scenario presents an ethical dilemma concerning data privacy and service provider responsibilities within the context of implementing Cisco Service Provider VPN Services, SPVI. The challenge lies in balancing the need for network troubleshooting and performance monitoring with the explicit privacy requirements of customer data traversing the VPN. Service providers have a legal and ethical obligation to protect customer data. An unauthorized access or disclosure, even for diagnostic purposes, can lead to severe regulatory penalties and loss of customer trust. The correct approach involves adhering strictly to established protocols for data access and privacy. This means that any access to customer VPN traffic for troubleshooting must be authorized, documented, and performed with the minimum necessary scope, ideally anonymized or aggregated data where possible. This aligns with the principles of data minimization and purpose limitation, which are fundamental to data protection regulations. By seeking explicit customer consent or following predefined, legally compliant procedures for data access during incidents, the service provider upholds its commitment to privacy and avoids potential breaches of trust and regulatory violations. An incorrect approach would be to bypass established privacy controls or to access customer data without proper authorization, even if it is for a seemingly urgent troubleshooting need. This directly violates data protection principles and could lead to significant legal repercussions, including fines and sanctions, depending on the specific regulatory framework governing the service provider's operations. Another incorrect approach would be to assume that general network monitoring tools are exempt from privacy considerations when applied to VPN traffic. All data traversing a VPN is considered sensitive and subject to privacy protection. Failing to recognize this and acting on that assumption constitutes a failure to uphold professional and regulatory standards. Professionals should employ a decision-making framework that prioritizes adherence to legal and ethical guidelines. This involves 1. Understanding the scope of data privacy regulations applicable to their services. 2. Establishing clear, documented procedures for data access and troubleshooting that are compliant with these regulations. 3. Seeking explicit authorization or consent when required. 4. Utilizing anonymized or aggregated data for monitoring and troubleshooting whenever feasible. 5. Regularly reviewing and updating these procedures to reflect evolving regulatory landscapes and best practices. In situations of doubt, consulting legal counsel or compliance officers is a critical step. Question 20. To address the challenge of a critical customer VPN service outage, a network engineer is pressured by the customer to immediately restore connectivity. The proposed solution involves temporarily disabling a critical security feature that is currently misbehaving, a measure that bypasses established security protocols and has not been pre-approved by the security team. The engineer is aware that this action could expose customer data and violate internal security policies. What is the most professionally responsible course of action? Option A. Implement the proposed workaround immediately to restore service, documenting the action afterward and informing the security team of the change. Option B. Escalate the issue to the security team and management, requesting an urgent review and authorization for a documented, temporary workaround, while simultaneously exploring alternative policy-compliant troubleshooting steps. Option C. Inform the customer that the service cannot be restored until the security feature is fixed through the standard, albeit time-consuming, change management process, without exploring any temporary solutions. Option D. Proceed with disabling the security feature as requested by the customer, assuming the risk as the primary goal is customer satisfaction and service restoration. Correct answer is B. Escalate the issue to the security team and management, requesting an urgent review and authorization for a documented, temporary workaround, while simultaneously exploring alternative, policy-compliant troubleshooting steps. Explanation. This scenario presents a professional challenge because it forces a network engineer to balance the immediate need for service restoration with the long-term implications of potentially compromising network security and customer trust. The engineer is under pressure to resolve a critical service outage, which could have significant business impact for the customer. However, the proposed solution involves bypassing established security protocols, which could expose sensitive customer data and violate service-level agreements, SLAs, and potentially regulatory compliance requirements related to data privacy and network integrity. Careful judgment is required to avoid a hasty decision that could lead to more severe consequences than the initial outage. The correct approach represents best professional practice because it prioritizes adherence to established security policies and regulatory frameworks, even under pressure. By escalating the issue to the security team and seeking a documented, authorized workaround, the engineer ensures that any deviation from standard procedures is reviewed, proved, and logged. This aligns with the principles of responsible network management, data protection, and compliance with relevant regulations that mandate secure handling of customer data and network infrastructure. It also upholds the integrity of the organization's security posture and customer confidence. An incorrect approach that involves implementing the proposed workaround without proper authorization and documentation would be professionally unacceptable. This action would represent a direct violation of internal security policies and potentially regulatory mandates concerning data security and breach notification. It creates an unmanaged vulnerability, making it difficult to track, audit, and remediate, and could lead to a significant security incident. Another incorrect approach, such as delaying the resolution indefinitely due to strict adherence to protocol without any attempt to find an authorized solution, would be professionally unacceptable as it fails to meet the customer's legitimate need for service restoration and could breach contractual obligations outlined in SLAs. This demonstrates a lack of proactive problem-solving in customer service. The professional reasoning framework for similar situations involves a multi-step decision-making process. 1. Assess the immediate impact of the outage and the proposed solution. 2. Consult relevant internal policy, security guidelines, and regulatory requirements. 3. If the proposed solution deviates from policy or raises security concerns, escalate the issue to the appropriate stakeholders, e.g., security team management. 4. Seek an authorized, documented, and temporary workaround if absolutely necessary, ensuring it is implemented with strict oversight and a clear plan for remediation. 5. Prioritize long-term security and compliance over short-term expediency.